Hi, Mark Donovan here from Falcon Imagery, and today I'm going to go over the topic of maximum design maneuvering airspeed, or VA. It's a very important V-speed that is often not thought about as much as it should be, and it should be something that all pilots should care about because if we exceed it, we potentially could cause structural damage or even failure to our aircraft. So follow along. All right, let's get into this. Why maneuvering speed changes with weight and why maneuvering speed is so important for pilots to understand. So what is maneuvering speed? And by the way, the V sub A that you see there, the A is for acceleration. Remember, force equals mass times acceleration. We're going to be talking a lot about load factors and gravity force. And again, force is a function of mass times acceleration. And that's why we have the A represented for our VA maneuvering speed. So again, maximum maneuvering speed is the airspeed at which an aircraft can withstand full, abrupt control deflections without structural damage. It's a crucial safety speed that ensures an aircraft will stall before structural damage or failure to the aircraft occurs from either turbulence or pilot input, and particularly when the pilot makes abrupt movements on the elevated controls, like pulling back on the stick or yoke. Max VA is weight dependent, meaning it decreases as the aircraft's weight decreases. It is not shown on the airspeed indicator. However, it is often placarded near the airspeed indicator for maximum gross weight only. You need to go to the POH to know what the ranges or limits are for lighter weights other than the max gross weight. So why is max VA a function of weight? So one simple formula we need to know when it comes to discussing max maneuvering speed is gravity force is equal to lift divided by weight. This ratio of lift to weight is known as load factor. And load factor is the total load on an aircraft structure as a multiple of its weight. When an aircraft is in unaccelerated flight, the aircraft is known as being in equilibrium. When we're in unaccelerated flight, lift equals weight and thrust equals drag. And in an equilibrium, an aircraft has a load factor of 1G force or 1G on it. And lastly, it's important to know this, there's nearly a direct one-to-one relationship between lift and angle of attack. So let's say we are in a cruise situation at 120 knots at max gross weight with a relatively high power setting and an angle of attack approximately of 3 degrees. Then say suddenly that we are hit by a sudden gust of wind that increases the angle of attack from 3 degrees to 6 degrees or doubles it. This results in a sudden doubling of lift while the weight remains the same. Thus, the aircraft suddenly goes from a 1G to a 2G load factor. Similarly, an instantaneous change of attack to say, let's say 9 degrees, either from a sudden gust of wind or from the pilot abruptly pulling back on the elevator control, causes the aircraft to see a tripling of lift, causing the aircraft to experience 3 Gs of load factor. Moreover, if we were to increase the angle of attack to, let's say, 12 or 15 or even 18 degrees, again from wind or just pulling back hard on the stick, this will result in an increase of lift and load factor of 4, 5, and 6G respectively. Since wings typically stall at an angle of attack of around 18 degrees, which is known as the critical angle of attack, any further increase in angle of attack would not result in any additional lift being generated or G-force being produced because a stalled wing doesn't really produce very much lift. Therefore, at 120 knots, as used in this example, the aircraft wouldn't stall until a maximum load factor of 6 Gs is applied. However, if our aircraft has a max load factor limit of 3.8 Gs, in the normal category and 4.4 in the utility category, then the aircraft could experience structural damage at this speed in turbulence or if the pilot again makes abrupt full deflection elevator control movements. Over on the right here, you see the load factor as specified by most aircraft and the types of aircraft we're flying. A normal category is 1.52 Gs negative to 3.8 positive Gs. And in the utilitarian category, minus 1.76 Gs to 4.4 Gs. So it's important to understand that there's no fixed ratio between angle of attack and airspeed, but they do have an inverse relationship for maintaining level flight. To maintain a constant amount of lift, a lower airspeed requires a higher angle of attack, and a higher airspeed requires a lower angle of attack. So if we slow our aircraft down from 120 knots to, let's say, 111 knots, the necessary angle of attack required to keep the aircraft in cruise flight will need to increase to, say, 4.5 degrees, roughly. Just making an estimate there. So again, if there's a sudden gust or we pull back on the elevator control abruptly, such that the angle of attack pitches up to, let's say, 9 degrees, we will gain an experience of about 2 Gs. If a sudden tripling of the angle of attack to, let's say, 13.5 degrees occurs, we will result in a 3G load happening. And a sudden quadrupling of the angle of attack to 8 degrees will result in a 4G load. But since the aircraft's wing will stall at that 18 degrees or approximately 18 degrees, it is technically not possible for the aircraft to experience the 4G loads as the wing will stall first because the wing has been pitched up high enough that it's exceeded that critical angle of attack. Consequently, the aircraft's max maneuvering speed in this case would be 111 knots at max gross weight. So at 111 knots, the aircraft will stall before it exceeds the limit load factor in turbulent air or full deflection of the elevator control. So when we have turbulent air, it is best to fly 10 to 15 knots below max VA speed to prevent a gust from temporarily raising the indicated airspeed above the max VA speed. So in turbulent air, you try to fly 10 to 15 knots below that VA speed so that you don't then cause that damage to the aircraft. But one very key thing to remember, when flying at a high cruise indicated airspeed, it's easier for a gust of wind to double, triple, or quadruple the angle of attack over its starting value because at the high cruise airspeed, the aircraft's wing is flying at a lower angle of attack to begin with. So consequently, it is easier for the aircraft to experience more G-forces for a given amount of turbulence when you're flying at higher airspeeds. Thus, slow down. Last thing I wanted to show you is this VG chart from the PHAC, Pilot Handbook of Aeronautical Knowledge. I want to first have you notice the stall line here, the accelerated stall line, how it kind of sweeps up from a 1G load factor up to about 4.4 Gs. And you see that curve goes up, and you'll see that 4.4 Gs is right at the corner where the max maneuvering speed is, based on a 4.4 G load factor, which is that utility category. And similarly, there's one on the negative side here at 1.76 Gs. And then notice the airspeeds at where the max VA occurs for both the positive and the negative load factors in this kind of generic figure. So beyond these airspeeds, structural damage or failure can occur to the aircraft when pulling those types of Gs. So again, when in turbulent air or doing aggressive flight maneuvers that could lead to abrupt and full control deflection, it is important to fly below max VA speed to prevent structural damage or failure to the aircraft. So before you get in your airplane again, pull out the Pilot Operating Handbook and take a look for the max maneuvering airspeeds defined in your aircraft. We fly Piper Warriors a lot, and they'll show 2 limits in there. One, the max gross weight, and I believe that other one at down around 1,500 pounds. So at max gross weight, I believe it's about 111 knots, and I believe it's about 88 knots at around 1,500 pounds. So what the POH recommends in that particular aircraft is just do a linear interpolation between those 2 airspeeds and weights to come up for your max maneuvering airspeed. Anyways, hopefully you found this video helpful, and if you did, make sure that like button and subscribe to the channel so you get notified on my next video.